Hello everyone, I'm Namrita, a PMRF scholar at IIT ISM Dhanbad. Uh, so, this is problem solving session week 8 for the course Differential Equation for Engineering. So, from today we'll start partial differential equation, the problem related to partial differential equation. Till now we have discussed the problem related to ordinary differential equation, and from now onwards we will discuss the question related to partial differential equation. So these are the questions we will discuss in this lecture. Basically, the first lecture is related to the topic classification of partial second order partial differential equation and reduce the partial equation into canonical form or normal form. These two type of questions we will deal in this section. So I want to give some quick review for the second order differential equation. The general form is AUXX plus BXY plus CUYY plus DUX plus EUY plus FU is equals to C. So this is the general form for the second order linear partial differential equation. Here A, B, C are the function of x and y, and should not be equal to 0. Isn't it? If these term will 0, then we'll get the differential equation in one order, which is not second order. Okay, now for classification, we will check the discriminant b square minus 4ac. Okay, if b square minus 4ac greater than 0, then we'll see our equation is hyperbolic or wave equation. If b square minus 4ac equal to 0, then we will say parabolic equation or heat equation. So I'm just telling the classification for second order partial differential equation. If b square minus 4ac greater than 0, then we'll say the equation is hyperbolic equal to 0. In this case, we will say the equation is parabolic, and if less than 0, then we will say our equation is elliptic equation or Laplace equation. So this is the classification for the second order linear partial differential equation. You have already done these things in your lecture series. I'm just recalling all those things. Okay, now let's move to the question number 1. The question 1 is says classify the partial differential equation. So can you tell me what type of equation these are using the classification which I have told just now? Try to solve and give me the answer. First one is 8uxx minus 2uxy minus 3uyy is equals to 0.
Hyperbolic, ma'am.
Okay, this is hyperbolic. Yes. Okay, let's solve. Question 1 is 8uxx minus 2uxy minus 3uyy is equals to 0. So here A is, this is A, this is B, and this is C. B square minus 4ac is equals to 4 plus 4 into 8 into 3, because I have already multiplied minus. So this is greater than 0, isn't it? That implies the equation is hyperbolic. Now check the second one is similarly you can check. What is B? B is 2. You can just compare with the general form of the second order PT, and you will get the value of ABC from where. This is less than 0, so isn't it? Is there any doubt? Similarly you can check question 3. So B square minus 4ac this will also 144, so the expression becomes 0. Is there any doubt in question 1? There are three equations. First one is hyperbolic, second one is elliptic, and third one is parabolic. Just check b square minus 4ac. If you will get greater than 0, then you will say hyperbolic. If less than 0, then you will say elliptic. Similarly, if equal to 0, then you will say the equation is parabolic. Okay, next question. So question second says, classify the partial differential equation graphically in the plane. First of all, you have to find out the condition, and after that you have to represent the all these three equations through graphically. The question is clear? Okay, first one, try to solve first one. First of all, you have to classify the partial differential equation. Please try to calculate. Uxx plus x minus 1 uxy minus 2x square ux plus 3xy uy plus 2y is equals to sine of x. What is the value of b square minus 4ac? In this case, b square, b is x minus 1 square minus 4, a is 1 and c is minus 2x square. Sorry, this is not uyy. Here the term is missing. Sorry. Xy plus uyy minus 2x square u of x. So c is a is 1, c is 1. Fine. Now you have to, first of all, you have to tell the condition. If it is parabolic, suppose it is parabolic, then that means x minus 1 whole square is equals to 4. From here, what are the roots? 3 and minus 1. So if the value of x is minus 1 and 3, then the equation will represent parabolic. Okay. Similarly, we have to find the condition for elliptic and hyperbolic. Okay. What is the condition for elliptic? This should be less than 0. That implies x minus 1 whole square minus 4 less than 0. That implies x minus 1 whole square less than 4. That implies fine. That means the value of x between minus 1 to 3 will represent the elliptic condition for the equation. And first is hyperbolic. What is the condition for hyperbolic? If this will greater than 0. That means x minus 1 whole square greater than 4. From here you will solve, then you will get, you can solve the inequality. Now we have to represent these three conditions graphically. Okay, so let's say this is x is equals to, sorry, so let me take another color. This is minus 1, this is 3. Okay, according to condition 1, when the value of x is minus 1 and minus 3, then these two lines will represent, parabolic. Fine. And when the value of x in between minus 1 to 3, that means this region, then it will represent elliptic. Fine. And the value of x when greater than 3 and less than minus 1, then the region will represent, the equation will represent in this region hyperbolic. Is it fine? Is there any doubt in question 2? You can ask. So this is first part for the question 1. Similarly, you have to solve question 2 second part. To please try to solve and give me the answer. Firstly, you have to find the condition for parabolic. Tell me the answer. You have to check delta b square minus 4ac. You have to check this equal to 0, then what we will get, what the reason we will get in this condition. Just you have to put delta is equals to 0. means 2x whole square plus 4y square is equals to 4. Fine. Can you say x square plus y square is equals to 1? So the PD is parabolic if x comma y satisfy so at the boundary of the circle the equation will represent parabolic equation. Now we have to find the condition for elliptic. So this is parabolic. Less than 0. Fine. If and only if 2 of x square 2 of x का whole square minus 4 1 minus 5 square less than 0. That means 2 of x square you can take 4 outside and cancel out. That means x square plus y square less than 0. So inside the circle you will say the PD represents elliptic equation. You can write here. Now third one is if this will greater than 0. That means you will solve, you will check x square plus y square greater than 0 in this condition outside. Fine. So you have to draw all these reasons. So inside elliptic region, outside area, and on the surface or not surface, on the boundary you will say parabolic. Fine. Is there any doubt? You can ask. Similarly, you have to check questions third part of question second. 1 plus y square uxx plus 1 plus x square uyy is equals to 0. Fine. Here you can see b is 0. This is a, this is b. Sorry, c. What is the value of del? Minus 4ac. 4, 1 plus y square, 1 plus x square. Fine. So when this equation will represent parabolic, if equal to 0. From here you can say x does not belongs to real number, y does not belongs to real, because the value of x is plus minus iota and y is also plus minus iota. So in real axis there is no xy where the equation will represent parabolic. So you will say nowhere parabola, because parabolic behavior, or you can say the equation is nowhere parabola. Now we can observe del less than 0 for all x comma y belongs to R square. That implies for all xy the equation is elliptic. So there is no point of xy where the equation represent parabolic. There is no xy point where equation will represent hyperbolic. The equation is elliptic equation. Fine. Is there any doubt? So no need to draw, because all the points in xy plane will represent elliptic PD in this equation. Fine. Okay. Let's move to the next question. Before going to the next question, I want to explain what is canonical form. For transforming the canonical form, we transform xy variable into xi eta variable. Fine. That means xi is a function of x and y, and eta is also function of xy. Function is from R2 to R. The transformation is from R2 to R2. In this case, this should exist. Fine. Inverse exists. That means x is a function of xi eta and y is a function of xi eta also. When this will exist, when Jacobian of xi of x xi of y, eta of x, eta of y will not equals to 0. So whenever we will consider the transformation, first of all we will check the Jacobian. We will choose x and y and xi and eta, the function of x and y. Then we will check the Jacobian for the x and y, sorry, xi and eta. This should not be equal to 0. If Jacobian is not equals to 0, you can move further. You can find the canonical form. We can say x is a function of xi and xi is a function of xy, and y is a function of eta, eta is a function of xy. Fine. So what is the value of del u upon del x? Using chain rule, we have to calculate the value of del u upon del x in the form of xi and eta. So u is a function of xi eta. First we have to differentiate with respect to eta, and eta is a function of x. Fine. And u is also function of eta, and eta is a function of x. Fine. This is the chain rule. You can write it also. Okay. Similarly, you can calculate uy. U of eta, eta of y, sorry, xi, and u of eta, eta of y. This is xi and this is eta. Similarly, you can calculate the value of uxx. You have already done these things in your lecture series. I'm just recalling these things because in further questions we will use these ux, uy, uxx, uyy, uxy. So you can calculate these chain rule using chain rule. Firstly, multiply this term with this bracket, and secondly, multiply this term with this bracket. Fine. Okay. Here you can differentiate product of two functions. Differentiation. I'm just writing. You can check the differentiation. You have already done these things in your lecture series. You can follow the lectures also for this chain rule. So from this you will get 4 terms, and similarly while calculating this you will get 4 terms because here product of 2 terms. Xi x mu xi plus eta x xi x u eta xi, sorry, xi eta or eta xi plus eta x so we will select the second term like this, take these terms together. You can write uxx as and rest of the term we can say lower order terms. Similarly, you will calculate uyy, then you will get, I'm going to write the expression. And the expression for xi. Sorry, after substituting these values, you will get the canonical form. Fine. Okay, let's move to the questions. You will understand better through the question. So just wait. Question number 3. Reduce the into a normal form. Okay, try to find the first of all characteristic equation. How to find the characteristic equation? Can anyone tell me? You have already done these things in your lectures. Try to go through the lectures then you will solve this problem easily. Dy by dx is equals to b. First one is plus b square minus 4ac. What is b square? Okay, let me write the expression first. Okay, first of all, calculate delta b square minus 4ac, which will less than 0. That means question is elliptic. In this case, we have already done dy by dx b plus under root b square minus 4ac on 2a, and second one is b minus under root b square minus 4ac upon 2a. Fine. These are the characteristic equation, in this case elliptic equation. Try to find out. Yes.
Madam, in some books it's given minus b, some books it is
Sorry,
given plus.
can you speak loudly?
Madam, in the formula q by dx equal to, some books it is given minus b, characteristic equation.
Some book
Some
is
books it is
given minus b. No,
some books
minus b is not correct. You
plus b is correct.
b is correct.
Okay.
Yes.
Okay. Okay.
So what is the value of b? B is minus 2. Fine. Minus 1 by 2 plus iota 9. Okay, you will get fine. Similarly, the second one. Okay, I'm just going to minus 3 by 2. Now, and similarly, just integrate, then you will get the characteristic equation. After integrating, you will get the expression. I'm just writing the expression. And second, 2y plus x plus iota 3x is equals to C2. Fine. Now we have to choose xi and eta because we have to reduce the given equation into canonical form. Jacobian for xi eta. Okay. Let's take xi is equals to 2y plus x minus. Okay, we can also consider the expression for xi 2y plus x and eta is 3x. You can check Jacobian. Xi of x is 1, xi of y is 2, eta of x is 3, 0, which is not equals to 0. Fine. So we can take these transformation. Now you have to calculate, given equation is uxx, uxy, uyy. So you have to calculate these three terms. Fine. So what is ux? We have already calculated u xi of x, u eta of x. Fine. From here you can put the value of xi of x, which is 1, and eta of x is 3. Fine. U of x. Okay. Now uxx. What is uxx? U xi x square to xi x eta x u xi eta plus eta x square u eta eta. Okay. Okay. Xi of x is 1, so xi of x square is also 1. The value of this 1, and this is 3 xi eta. What is eta x? 3, and square is 9. So this is the expression for uxx. Similarly, you have to calculate uxy and uyy. What is the value of uy? U xi of y, u eta of y. Well, let me write the xi and eta for convenient. So this is 2, and eta y is 0, so the expression becomes 0. Sorry, this is y. Fine. Okay, you have to calculate uyy. You can directly differentiate this term, or you can use the formula. Size. So this is 0, this is 0, and what is the value of this? 2, so this is 4. Fine. Similarly, you have to calculate uxy. You can calculate from here also. Or you can write the formula. So the value of xi x is 1, xi y is 2. So 2u xi. Fine. And eta y is 0. Eta x is 3. Xi y is 2. So from here you will get 6. Because this is 3 and this is 2. And here 0. So you will get the value of uxy. Now you have to substitute the value of, let's say this is equation 1, this is 2 and this is 3. You have to substitute the value. 2 uxx. What is the value of uxx? From equation 1, the value of uxx is u xi plus 6 u xi eta plus 9 u eta eta. This is the value of uxx. You can see. Fine. And 2 uxy. What is the value of uxy? Uxy, the value of uxy is, from equation 3rd you can put, and from equation 2nd you can put the value of uxyy. So the value of uyy is, now solve. What is the value of u xi eta? Sorry, this is xi eta. So this term will cancel out, and this is also xi, sorry. So the expression becomes 18 u xi and 18 u eta. That means is that clear? If there is any doubt, you can ask. In question number 3, You have to just calculate ux x in terms of u xi xi, u eta eta. Means you have to transform the xy into xi eta. Then you will get the normal form. Okay, let's move to the next question. Yes.
Madam, this selection eta and xi, it can be any other form.
Yes, it can be any form, but the
Only
restriction is
condition. Oh,
Jacobian should not be equal to 0.
okay.
Yes. This is a normal form. You can get another normal form also. If you select any other expression of xi eta, you will get maybe a different normal form, but this is a normal form. Fine.
But the answer should be unique, madam.
Normal form is unique. Okay, after any expression you will get this expression will same. Yes, the normal form will same, but the transformation can be any other transformation. You can select the expression of xi eta, any other transformation, and you can check the normal form will be same. Okay.
Okay.
Question number 4 is, again you have to reduce the into a normal form. So you have to again calculate uxx, uxy, but first of all you have to observe what kind of PD is this. Here A is 1, B is -2 and C is 0. B square minus 4AC is 0. That means hyperbolic. Okay. So in this case you have to calculate the characteristic equation. B is -2 plus B square, this is 0. Okay. So this is 0, and from here you will get -2. After integrating you will get y is equals to constant, and from here you will get y plus 2 of x is equals to c2. Okay, these are the characteristic equation for the given partial differential equation. Now choose the transformation. What transformation we can choose from here? Transformation xi and eta will be the function of x and y itself, and the Jacobian of xi and eta should not be equal to 0. So tell me the transformation. Can we choose xi is equals to y and eta is equals to y plus 2 of x? Please check the Jacobian for these transformations. Xi is y, so xi of x is 0, xi of y is 1, eta of x is 2, eta of y is 1. Again, not equals to 0. So we can take what is u of x, u of xi, xi of x, u of eta, eta of x. Since xi is y and eta is 5 plus 2 of x, so xi of x is 0, eta of x is 2, 2 of eta. Fine. U of x axis again xi or you can use the formula also. Fine. The value of the expression is 0. So from here you will get this is 2 of x, 2. So the expression becomes 4u eta eta. Fine. Similarly, you can calculate uxy. Okay, for this you have to calculate u of y. What is u of y? U of xi of y plus u of eta, eta of y. This is 1. So, and eta of y is also 1. Fine. Now, what is the value of u, x? Because the expression doesn't contain y expression, so no need to calculate u, y. So, what is the expression for uxy? You can differentiate with respect to x. That means first with respect to xi and second with respect to eta. The value of this expression is 0. Okay, and the expression for this is 2. So what you will get from here, if you multiply and 2u eta xi plus 2u eta, fine. So now you have to just substitute the value of u xx, u, this is value of u xx. No need to confusion in the symbol. And from here uxy you can put these two value in the given partial differential equation. The equation is uxx minus 2xy is equals to 0. Uxx minus 2uxy is equals to 0. What is the value of uxx? 4u eta. And the value of uxy is 2u eta xi plus 2u eta. Fine. So this term will cancel out after multiplying, and the expression 4 u eta xi is equals to 0, that means u eta xi is equals to 0. It's a normal form. Fine. Is this clear? Question number 4. Okay, there are 3 question more, 5, 6, 7. So question 3, 4, similar to 3 and 4, we have to calculate question number 5. 5 says reduce the PD 2xx plus 2x plus 3 uxy plus 6x uyy is equals to 0. Now tell me what this PD is represent. Calculate delta and tell me.
It is parabolic for x equals to 3 by 2, otherwise hyperbolic.
Okay, good answer. This is the correct answer. After calculating, you will get 2x minus 3 greater than. So this is positive term, but this will greater than 0 if x not equals to 3 by 2, because at x is equals to 3 by 2 the expression becomes 0. Then the differential equation will represent parabolic, otherwise this will represent hyperbolic. Okay, now in this case you have to calculate the characteristic equation. Can you calculate the characteristic equation? This will become after calculating the term inside the under root, this is minus, b is minus 2x plus 3. You can check here, the equation is given. Just wait. I think the question is okay. Fine. This is not minus. This is plus. This will cancel out. Another characteristic equation, 2x plus 3 minus 2x minus 3 on 4. These will cancel out. Sorry, this is 2. My fault. Okay. Now you have to integrate and you can find the characteristic equation. First one is yes.
Ma'am, in the part under square, is it always positive?
Can you repeat?
The part under square root, that is 2x minus 3,
Okay.
for any value of x, it should be positive.
Yes, the value of under root b square minus 4ac in this case is positive. In this case, because the PDs represent hyperbolic, so b square minus 4ac is greater than 0. You have already calculated b square minus 4ac, which is positive. But the condition is x should not be equals to 3 by 2. Fine.
No, I can say if x equals to suppose minus 5.
Minus 5. This is whole square, so it will always positive.
No, when we extract 2x minus 3 from under root,
You
the
will
value,
take any value. Let's say this expression become like this, but the power is a square, whole
okay,
square, so this will automatically
okay,
become positive.
positive. So when we take under root, it should be minus x for x negative.
For x negative, if we take x negative, let's say x is minus 1, okay,
Okay,
then what you will get? Minus 5, but whole square, so it will always become positive.
so when we write in algebraic expression, it should be minus 2x minus 3.
That should be plus 3, madam.
What are you
Second,
saying?
dy by dx equal to plus 3, not minus. The minus,
This should be plus 3.
No, no, ma'am. Minus 3 is okay, but I can say when we extract a expression from under root, it should be
Okay.
always positive.
madam, one minus
Okay,
outside the
you
bracket.
will say this is plus or minus. Both will here. Am I right?
Yes, yes.
So I'm taking the next condition also. The second condition is b plus minus. So I'm taking the plus one is here and minus one is here.
Yes, madam, 2x plus 3 minus of 2x minus 3. Is it,
Minus
madam?
of 2 of x minus 3. So after removing
Outside
bracket,
minus,
okay,
minus into
this is
minus plus.
plus. Okay, this is plus
Yes.
3.
Yes,
Now
madam.
is
Yes,
it
madam.
fine?
That's, okay.
Okay, okay. So this is printing mistake, you can say. From 1, you will get this characteristic equation and you can integrate, then you will get the characteristic equation. Y minus x square upon 2, 2 cancel, and here y minus 3 of x is equals to C2. Fine. These are two characteristic equation. Now we have to transform. So we have to choose xi and eta. Can we choose this is xi, this is eta, or you can say this is eta, this is xi. Okay, let's check. If we take xi y minus 3x, eta is y minus x square, then you can check Jacobian first of all. Xi of x is minus 2 of x. Xi of y is 1. So because we are taking minus is not equals to 3 by 2. I think this is 3 by 2. X is not equals to 3 by 2. 3 by 2. So this will never become 0. Fine. Now we can take xi or eta in this manner. So now your task is you have to find ux. I want to say square root 2x minus 3 is equals to minus 2x plus 3. Are you saying my square root of 2x minus 3 is minus 2x minus 3? Isn't it? So I'm taking the second condition here because this is plus minus. Am I right? First condition I'm taking here and second one is I'm taking here. The minus condition I'm taking here.
Ma'am, when x greater than 3 by 2, then it's okay, 2x minus 3. But when x less than 3 by 2, it should be minus. When x greater than 3 by 2, root under root 2x plus 3 whole square equals 2x minus 3. It is okay.
You have to 2x minus 3 whole square. Fine. So after taking under root and square outside, you have to select, you will get just 2x minus 3 positive because
Ma'am, it is 2x minus 3 for x greater than 3 by 2.
this
When
is
x
whole
less than 3
square
by 2,
term. So for any value of x, the under root term is positive because
yes,
2x minus whole square.
yes, ma'am. For when x less than 3 by 2, it
Then
should be
it will
negative.
also be positive. You can check ux minus 3 whole square. You will take x less than minus 3 by 2. Then you will also get the expression will positive because 2x minus 3 whole square. Whenever whole square
Ma'am,
is there,
in the expression, if we put x less than 3 by 2 some term, then it should be the value will come negative.
no. You are getting wrong. This is whole square term. After squaring negative term, you will get positive.
Yes, but ma'am, if we put x equals minus 1 in both sides,
Again, you are saying the
what will
same
happen?
thing. If you take any value of x, positive or negative, the expression of under bracket, if say negative, then square will become, the term will become automatically positive. So either you can take the value of x negative, you will also get the positive term because of whole square, and if we take positive term, then it will
Ma'am, when
automatically.
x equals minus 1, what is the value?
Okay, let me calculate.
Equals
Fine,
5. Equals 5.
equals to 5. Yes,
But when in your expression, if we put my x equals minus 1, it becomes minus 5.
I'm just taking minus 1. X is minus 1.
When under root 2x minus 3 whole square equals 2x minus 3. If we put
This
x
is a
equals
square
minus 1 in your
term, so
expression,
you will take any value of x, you will get positive value always.
for getting positive value, we should check the right hand side minus 2x minus 3, no?
But it's the whole square. What is the graph of x square? It will always positive, na?
Okay.
Fine.
I want to say the reflection of positiveness should be given in the expression also. When we write under root 2x minus 3 whole square equals 2x minus 3, it should be when x less than 3 by 2, it should be minus 2x plus 3.
After getting out of under root, the expression you will get 2x minus 3.
2x
But
minus 3 for x less than 3 by 2, x greater than 3 by 2.
no, for all x. You can check under root whole square is there. So you will get for all x, the value of under root is positive. Can anyone explain to him?
Madam, first you must take square, then you will go for square root. For negative or positive, square will be always positive.
Ma'am, I want to say root under root x square equals mod x.
Yes.
That's why under root 2x minus 3 whole square equals mod 2x minus 3.
Okay. This is mod. Yes.
Mod 2x minus 3.
So
That means when
plus
it's greater
or
than 3
minus.
by 2, it should be positive. When it's less than 3 by 2, it should be negative.
No.
Okay. X. Okay.
Less than 3 by 2, it should be minus 2x
After
plus.
removing after coming out of under root, then you
Okay.
can say this where this is positive, where this is negative, but this term is positive, na?
Okay. That's why when under root 2x minus 3 whole square equals mod of 2x minus 3, that
Yes.
means when x greater than 3 by 2, it should be 2x minus 3. When x less than 3 by 2, it should be minus 2x plus 3.
Okay. You are saying this is the value of mod. So here, okay, you can check if we take plus, then you will get one expression for x greater than 3 by 2.
Okay.
And
Yes.
after taking another one, you will get second one. And in the second case, you will get two cases. So both cases will similar.
Ma'am, in the second case, the minus is for characteristic equation. For mod, minus within
Minus
bracket minus 2x
here
plus
also
3.
you will get this term. Fine. Here also mod is there.
Yes, for each expression,
Yes.
for two expression, x less than 3 by 2 and x greater than 3 by 2, we get two expression.
Yes. Then after taking these four cases, two from upper, two from lower, you will
Yes.
you will get
Yes.
just these two characteristic equation. Fine. This
Okay.
is for x greater than 2, because when you put plus, then you will get this. You will put when you put minus, you will get this. Fine. Is there any doubt?
Ma'am, in the first expression, please.
Okay,
In the
just
first
I am
expression.
taking plus 1 for the case x greater than 3 by 2. Okay.
Okay.
Okay, and in the second case I am taking minus for the case x less than 3 by 2. Fine.
Ma'am, for each case, we should take two expression.
Okay, but the case will give ultimately these two expression only, because in second term when you take minus and okay, let me explain little more.
Madam, this should be taken first square, then square root.
Okay.
First it should be square, then square root. Then we'll get plus or minus. Reverse order you will not get, madam.
So this is x greater than 3 by 2. Fine.
Okay, okay.
And what will be the expression for less than? For x less than 3 by 2? This will minus. Fine.
For x less than 3 by 2, it will be
Minus
Take some
3,
2x
only,
example and
minus
only
2x
3.
plus 3, I think.
No, ma'am, only 3.
For less than,
In the first case, for x less than 3 by 2, it should be only 3.
for the first case, is it correct now?
For x
Okay.
greater than 3 by 2, it should be 2x.
Yes.
For x less than 3 by 2, it should be 2x plus 3 plus minus 2x plus 3.
Yes. This is the same thing. Fine.
Okay,
Then you will get 3. Fine.
okay, okay.
For this case. And after, if you take another characteristic equation, then you will get the similar two cases.
Okay, ma'am, okay, okay.
And you will get similar these two characteristic equation. Fine.
Okay, ma'am, okay, okay.
Okay. Okay. Let's move to the topic. Uh, we have to calculate u of x. U of xi of x, u of eta of x. Fine. This is minus 3 xi of x. Now you can mute yourself if there is no doubt. Okay, thank you. Eta of x is 2 of x. Fine. Eta of, sorry, u of eta. Similarly, u of y. U of eta of y. What is xi of y? It is 1, and eta of y, it is also 1. Fine. Now we have to calculate u xx. Okay. Uh, the value of u xx is, we have already calculated. You can take this term also. Fine. Now what is the value of psi x square? It is 3. So 3 square is 9. U xx, it is 9 u xi plus 2 u xi eta into xi of x is minus 3, eta of x is eta of x, since eta is y minus x square. Okay, let me write here. What is the value of eta x? Minus 2 of x. Fine. And u eta, the value of eta y square, sorry, eta x square. Eta x is minus 2x whole square plus u xi, and xi x is 0 plus u eta x which is minus 2. Fine. Similarly, you have to calculate uyy. The value of uyy we have seen 2u xi eta y plus u eta y square plus u y plus u eta y. Fine. What is the value of xi y square? It is 1, so we'll get just plus 2 xi eta. What is xi y? It is 1. Eta y is 1. Eta y square, it is also 1 whole square plus xi y. Xi y is 1 and xi y is 0. Eta y is 1, y is 0. Now you can calculate xy. Xi x, xi y, u xi eta, xi of x, eta of y, xi of y, eta of x plus u of eta x, eta y plus u of xi of xy plus u of eta of xy. Now xi of x is minus 3, xi of y is 1, u of xi eta. Xi of x is minus 3 into 1 plus xi of y is 1, eta of x is minus 2 of x plus u eta x is minus 2 of x, eta y is 1, and rest of the term will 0. You can check. So you have to substitute in the expression. The expression is uxx plus 2x plus 3 uxy plus 6x uyy is equals to 0. You can substitute. Okay, after substituting, I'm going to collect the coefficient of u xi from here, and from here. After substituting and calculating the coefficient, you will get this expression u eta, you will get 4x square plus 6x. You can check the calculation. Just I'm putting the value of uxx, uxy, uyy. Sorry, this is minus 3 minus 2 of x fine. Okay, from here 7u xi. From here you will calculate 4x square plus 6x minus 4x square. This will cancel out 6x. This will become 0. You can check. And so the second term is 0. After calculating this will 24x, and after multiplying you will get, I'm going to write the expression. So this is, and if we take 4 outside, x square 3x minus 9. What is the value of x square minus 3x? Because we, in the canonical form, we have to express each term in the form of xi and eta. So let me check what is xi. Xi is y minus 3x, and eta is y minus x square. If we minus from 1 to 2, let's say this is 1, this is 2, then you will get the expression 3x minus x square. Okay, xi minus eta, this will become 0, minus 3 plus x square. So the expression for this x square minus 3 is xi minus eta. Fine. Okay, this will multiply it by with this expression minus 4. So this is the canonical form. Fine. Okay, I think there are two questions, but I'm going to solve just one question because we have less time. Tell me which question. Uh,
For other
yes.
question, last question you can solve, madam.
Okay,
Sixth question you can give answer.
Okay, so you are saying question number 7.
Yeah.
Okay.
Question number 6 you can give answer. We will check the answer.
Okay, I'll give the answer for question number 6, and I'm going to solve the question number 7. So the answer is question number 6. Okay, just write the answer for question number 6. The answer is, you can check if the answer is same or not. If there is any calculation mistake, you can correct. But I'm getting the answer this. Okay, the question number 7 is, question number 7 is you. If you will check delta b square minus 4ac 4ac, and the expression is 4, this minus minus plus, so this is sin square x plus cos square x, which will become 1, that means positive, that means hyperbola. So in this case the characteristic equation minus 2 sin x, this is b, plus under root 4ac upon 2a. From here you will get minus sin x plus 1. And another characteristic equation, you will get minus sin x minus 1. You can check. Okay, now from integrating here you will get minus x plus okay x plus cos x. Fine. That means y minus cos of x minus x is equals to eta. Sorry, c1. And from here y minus x minus, this will become plus minus cos of x plus x, let's say c2. Now you can take the transformation. Let's say this is xi, this is eta, or this is eta, this is xi. Let's say xi is y and eta is, you can check Jacobian also. This is 2 not equals to 0. You can take these transformation and you can calculate ux. What is ux? Xi of x u xi into xi of x. Xi of x is 1 and minus cos x will become sin x plus u of eta. Eta of x is minus cos x is sin x minus 1. Fine. Similarly, u of y. U of xi into xi of y. Xi of y is 1. U of eta. Eta of y is 1. Now you can calculate u of xx. U xi of x square. This is xi of x. So 1 plus sine of x whole square. 2 u xi eta. And xi of x into eta of x. Xi of x is 1 plus sine x and xi of y is sin x minus 1. So after multiplying you will get sine square minus 1. Fine. Here xi of x into xi of y. And the next term is u eta x square. Eta x is sin x minus 1. Sin x minus 1 whole square. Fine. And u xi into xi xx. Xi x is 1 plus sin x and xi xx is cos x plus u eta xx. Eta x is sin x minus 1 and eta xx, this will become cos x. Similarly, u y y, u xi y square, xi y is 1 square 1, 2 u xi eta into xi y eta y, xi y is 1, eta y is 1, u eta eta y square, eta y is 1, so 1 square means 1. Similarly u x y, u xi of x, xi of y means xi, okay, I'm going to write xi of x and xi of y multiplying. Xi of y is 1, xi of x is 1 plus sin x plus u xi eta into xi of x into eta of y, xi of x into eta of y plus xi of y into eta of x. Eta of x is 1, then you will get xi of y plus u eta eta of x, eta of y, eta of x, eta of y 1 plus sin of x, eta of y is 1. Other terms will become 0. Now you have to substitute into the expression. The expression is 2uxx plus 2x plus 3 uxy plus 6x uyy equals to 0. Now I'm going to substitute and going to collect the value, the coefficient of u xi. From here 1 plus sin x whole square so sorry, this is not the equation, I'm writing the expression is sin square x just substitute and collect the coefficient. I'm writing the yes.
Madam, you are doing seventh question, madam.
Yes, question okay, 7. Sorry.
You are
Again.
taking sixth.
Yes, sorry. Question 7 is uxx minus 2 sin of x uxy minus cos square x uyy. Fine. This is equation, given equation. Now I'm going to collect the coefficient for u xi. From here 1 plus sin x whole square and from here after substituting you will get 2 sin of x into 1 plus sin x, and from here you will get cos square x and the coefficient is 1. Fine. Plus, okay, I need to write in the next place u xi eta, u xi eta. Okay, you can check. I'm going to write the expression. And the coefficient for u eta is Sin x minus 1 whole square minus 2 of x sin x 1 plus sin x minus cos square x, fine. And for this cos x uy, what is the value of uy? Uy is u xi plus u eta. And here cos x u xi plus u eta, and this is the given ux, u xi plus u eta. You can calculate, then you will get the expression of the bracket term will become 0, and this will cancel out, and after calculating the first term, not this expression, the first term will become 0. The first term is, you can check the expression, this will become 0. 1 square plus sine square minus 2 sin x minus 2 sine square, so this will become 0, you can check. And after calculating this, you will get minus 4. Okay, I'm going to write the final expression. You can also solve this expression, then you will get just 4 sine of x. You can check the answer. I'm getting the answer which I'm going to write. You can take 4 outside. Now you have to write the expression for x in terms of xi and eta. Xi and eta. What is xi and eta? Since y minus cos of x plus x is xi and y minus cos of x minus x is eta, so after calculating from here you will get, substituting let's say, then you will get eta minus xi upon 2. So this is the answer. Is the yes.
What about general solution, madam?
uh, you can calculate the general solution, but the question just saying reduce the PD into canonical form. I'm not talking about general solution. Maybe
No,
in the
madam.
next class. Yes.
In the question it is there, madam.
Question is
Seventh question, last word.
okay, and find its general solution. Okay, you can try. I will discuss this general solution in the next lecture.
Madam,
Yes.
hello. Next week Sunday we'll have NPTEL exam, Laplace transformation.
Which exam?
The afternoon. Next Sunday, madam.
Next Sunday, the exam for differential equation?
No, no, madam. Laplace transformation. Another.
Okay, so we can discuss this also, general solution.
No, madam. I cannot attend the class. What is the? Is there any
So you
possible to
can
conduct?
check the recorded lectures.
Uh-huh.
After
Okay.
every lectures, I have been uploaded every lectures on the YouTube and provided
Okay.
you the link. So you can reach through the link.
Okay, madam.
Okay. Thank you guys. That is all from my side. Okay.